Problem Introduction. Hey everyone, and welcome back to the channel. Today, we're tackling LeetCode problem number 39, combination sum. This is a classic dynamic programming problem rated as medium difficulty, and it's a fantastic problem to understand how to break down complex problems into smaller, manageable pieces. The problem statement asks us to find all unique combinations in a given array of integers that sum up to a specific target. We're allowed to use each number in the input array as many times as we need. For example, if our array is 2, 3, 6, 7, and the target is 7, then one solution would be 7 itself. Another solution might be 2, 2, 3, because 2 plus 2 plus 3 also equals 7. The key here is that we need to find all unique combinations, so we'll need an algorithm that systematically explores all possibilities without getting stuck in infinite loops or redundant calculations. We'll dive into various approaches, starting with a simple brute force method before moving on to the more optimal solution. Let's get started. Understanding with examples. Let's solidify our understanding with a couple of examples. Imagine our input array is 2, 3, 5, and our target is 8. Let's think through some combinations that add up to 8. We could have 2, 2, 2, 2, since 4 2's equal 8. We could also have 2, 3, 3, because 2 plus 3 plus 3 equals 8. And finally, we could have 3, 5, which is 8 as well. These are all valid combinations. Now consider another example. Input array 2, 7, 10, and target 9. Here, the only solution is 2, 2, 2, 3, assuming we can reuse numbers, but this example doesn't allow for 2, 7, only if we were allowed to use each number once. We need to be very careful about reusing numbers here. That's a crucial aspect of this problem. As you can see, finding all these combinations can be tricky, and a well-structured approach is crucial to avoid missing any valid solution or falling into endless looping. That's what makes this a great dynamic programming challenge. Brute force approach. A straightforward but inefficient approach is brute force. We could try every possible combination of numbers from the input array. We can generate all possible combinations, add them up, and check if the sum matches the target. This involves a lot of nested loops and it's computationally expensive. Imagine an array with many numbers and a large target. The number of combinations explodes really quickly. The time complexity would be exponential, not ideal. For example, if you have n numbers and each number could be used multiple times in a combination, this quickly becomes a combinatorial explosion. While it works for smaller inputs, it's not scalable. This approach is useful to help us understand the problem and see how optimization techniques are crucial, but that's why we need a smarter approach, a dynamic programming approach. Optimal solution. The optimal solution utilizes a backtracking approach, which is a form of recursion. We will explore different combinations recursively, adding numbers to a temporary combination and subtracting them from the remaining target sum. If the target reaches 0, we have found a solution and we add that combination to our result. If the target becomes negative, we backtrack, removing the last added number. This method helps us efficiently explore the solution space without redundant calculations, avoiding the exponential time complexity of the brute force method. The key to the efficiency is this systematic exploration and the early termination of fruitless paths, allowing for faster processing. Code implementation. Let's see the code in Python. We'll use the backtracking approach we discussed. We'll have a recursive function that explores combinations. It takes the current index, the remaining target sum, a temporary list to store the current combination, and the result list to store all combinations. The base cases handle when we find a valid combination or when we exhaust all possibilities. Otherwise, we recursively explore adding numbers to our combination. The use of recursion ensures we explore all valid paths efficiently without the exponential complexity of the brute force method. Now, let's walk through the code line by line so you can get a clear grasp of each step. Time and space complexity. The time complexity of our optimized solution is significantly better than the brute force approach. While it's still difficult to give an exact formula, it's bounded by the number of possible combinations. In the worst-case scenario, the algorithm explores a lot of paths, making it not quite linear. However, it avoids the exponential complexity of brute force. The space complexity is primarily determined by the depth of our recursion, which, in the worst case, is proportional to the target sum. So we can say it's O of the target in space. This makes our algorithm a significant improvement over the brute force method. Engagement break. So we've covered quite a bit today, and I hope you're finding this helpful. Before we wrap up, I'd love to hear your thoughts. Did you find this explanation helpful? What other LeetCode problems would you like to see covered? Don't forget to smash that like button if you enjoyed this video, and subscribe to the channel for more coding tutorials and algorithm walkthroughs. And leave a comment below. I read every single one. Thanks for watching, and happy coding!